will guarantee you, whoever does it, and there will be many that do, I think that'll do AGI, there'll be different flavors of it, just like there are different flavors of Gen AI today. You will have people that will start bowing to the AGI god. You watch. It's going to happen. And that's not going to be a healthy thing.
Hello and welcome to the ImagineAI podcast. Today I have my guest Ed Heinbockel, the co-founder and president and CEO of Savant X, and also the founder and president of Visual Purple. We are so happy to have him on the podcast today because he's going to be a speaker at the ImagineAI Live conference that's happening at the end of March in Las Vegas, and it's already turning out to be a huge success. We've got 300 signed up attendees and a huge list of speakers, and there's still room to get in. So please go get your tickets now. But Ed, thank you for being here today. How are you doing?
I'm doing great. Thanks for having me. Appreciate it.
First, could you just explain what is Savant X?
The best way is to describe it as we're essentially a bunch of idiot savants. We'll start there. So we like to focus, and we like to do a short list of things really, really well. I spun Savant X out in 2015 with my business partner, David Osby. He's our chief science officer and CTO, and we've been working together for longer than I would care to admit, and we're like best friends. He's just a wonderful guy, brilliant guy, mathematician, programmer, system designer, quantum guy now, you name it. Kind of a Renaissance man, really, when it gets down to it. And we had this notion that we were doing some work at Visual Purple. Visual Purple, just to give everyone some context, is a company that I've had for 26 years. I came out of gaming, PC gaming in the 80s and 90s. Worked for a company called Sierra Online in the 80s. In the 90s, I got the entrepreneurial itch and started up a company I had for most of the 90s called Tsunami Media. And one day I got a call from the FBI asking if I was going to respond to something called a broad agency announcement. I didn't even know what that was, but long story short, they convinced me to respond, got our first contract a year later. I sold Tsunami Media and then focused on serious games and had Visual Purple and been doing that for 26 years now, primarily in the government space and some corporate. We've done a lot of work in the commercial and nuclear industry. So we tend to focus on mission critical kinds of simulations of things you hope never happen. So for instance, in a nuclear power plant, being able to allow security personnel to go into areas that they normally would not go because of the resident hazards in terms of radiation, et cetera. And we do all that through VR simulations. So we were working with a lot of really interesting folks, interesting agencies all these years. And then David and we started building some technology, what they call in the government space, IR&D dollars, so internal research and development, on our own dime. And we ended up building some interesting technology that's forerunner to a technology we deployed last quarter, Q4 2023, something called Seeker. And we can talk more about that, but that's our first Gen AI offering. But to get to that point, we were building and deploying advanced analytics, search and discovery systems, OSINT tools, open source intelligence gathering tools for places like Defense Intelligence Agency. And we're doing this all under the umbrella of Visual Purple. And we finally said, well, this is kind of silly because Visual Purple is doing all this mission critical training for clients, DOD, et cetera. Here we are doing this analytic stuff. So we spun out Savant X in 2015. Both companies are all bootstrapped, no outside capital. And that's kind of been our go-to-market strategy. And we've been successful at it. And the normal challenges being a bootstrap company, but we got a great team. We have a great track record. And Savant X has grown from, on the analytics side, had this notion that we should be doing something in quantum. And we started down that path a number of years ago, and we developed a core competency in quantum computing. And when you think quantum computing, you probably want to think of hybrid quantum, because a quantum computer doesn't have a memory. You can make calls to an API to do really cool things, to do massive computes that to do classically just doesn't make any sense from any perspective. Bake those kinds of capabilities into a solution and you can do some wondrous things. So that's been our focus, corporate focus, is to bring quantum to bear. And the last few years, really bring it to bear with AI. And that's what sort of this pulse wave of activity and IP that we've laid down over the years has all culminated. It's been really exciting for us.
That sounds extremely exciting. And what a interesting past and serious games. I mean, as a video game player myself, and very familiar with all these serious games where, if I was starting at a new company and I had to deal with nuclear material, I sure would love to play a simulated version of my job in the worst case scenarios. I have that experience under my belt before, heaven forbid, having to actually do it in the real world. So very important stuff you were doing there. Who's the end user for Savant X right now? Is it still in the government space?
The short answer is we still have government work. I'll give you an example. We do work for the Air Force, and we're using quantum. We're on the second phase on an engagement with the Air Force to optimize their global network of flights. The Air Force has a division or group they call Air Mobility Command. So those are 5,600 flights a week that go around the planet flying material, personnel around. So they're the cargo haulers. And they've got, I think it's about 450 aircraft. So they came to us a couple of years ago and said, hey, could you help us? I'm like, I don't know. What do you need? Like, well, it was really funny. This group out of the Pentagon knew what we were doing in the intermodal transportation space, and we had a lot of success. But to answer your question, it was really fun. It was kind of it was a comedy routine with the guys at the Pentagon. I love these guys. They're kind of these nerds reached out to us, really bright folks, and they're like, we're asking these questions. What do you need? What do you need? And tell us, and yada, yada, yada. And at the end of the day, they go, if we just need to burn less fuel a year, we need to move at least as much stuff, if not more, and burn less fuel. I go, okay, I can get my head wrapped around that. Then the question was, do you know how many gallons of fuel we burn a year? And I'm like, I have no idea. Well, come on, guess. We went back and forth, and finally they're like, we burn 1 billion gallons a year. And if we could save some of that burn, that'd be awesome. I'm like, well, I have no idea if we could or couldn't. My sense is we should be able to help you somehow, but it might only be 1% or 2% if we're lucky. I have no idea. Haven't seen the data. We haven't run a process on this. It'd be great if we could save 1 or 2%. Anyway, so we got a contract. They sole sourced us, which is kind of interesting. It's hard to do in government contracting. They have to do justifications to do that. So got a sole source contract. We had as a 1-year engagement for phase 1, and we actually finished it in 6 months. We got their data. They were really good about getting us 15 years of data. And we took that data and we created a digital twin. We primarily use the D-Wave. It's an annealer quantum computer. If you know what you're doing with it, you can do some pretty incredible things. So we got a great team that really has a lot of experience, and we were able to suss out efficiencies. The team back, we said, hey, you're not going to believe what we got here. I go, show me so show me all this in the digital twin. They're like, some of these runs are up to 42% increase in efficiency. I go, 42%? Nobody's going to believe us, kind of thing. And they were running 32 to 42. We ended up briefing it up with the team out of Air Force Research Lab they're working with. And they're like, this is great. No one's going to believe us. How about if we call it 8%? I said, whatever you want. I mean, here's the numbers. You can run the digital twin, but this is what we can do with quantum, with optimizing these networks. So I got briefed up to the assistant SecDef, and he said, hey, let's go on, move this forward. So we are. It's an example of some of the ongoing work we do on the government side.
Well, that's amazing, first of all. Even to save 1 to 2% on 1 billion gallons a year is good savings. That you were able to get it to 42% in some cases is astounding, and save resources, help the planet. It's great. Are you a podcaster? Do you appreciate the power of AI to make your life more productive? Well, do I have the tool for you? Podcast AI is a company that streamlines all your post-production needs. It honestly saves me an hour or 2 of work every episode, and it gives me tons of ideas for marketing and social media posts. Go over to podcastai.com now to see for yourself. That gives a really good picture of the types of clients that you're working with. 2 questions around the quantum computer. Do you have your own quantum computer, or are you using somebody else's quantum computer? And then where does AI or generative AI fit into that?
Good questions. No, we do not have our own quantum computer. I don't know what the cost is for a D-Wave these days, but last I checked, they were like $10 million. They're pretty interesting because these things are like the D-Wave. They're sort of a freezer and a freezer and a freezer. So they literally operate at just above absolute zero, just a fraction of a degree above absolute zero. And the reason they do that is because the chip the size of your fingernail can't have any permutations. It has to be as quiet as it can be thermally, every which way to Sunday, as for it to do what it needs to do, because they're very sensitive. because they're working at the quantum level. That and other factors equate to very expensive boxes in terms of the cost of these things. So what we do is like Azure, it's a cloud service. We have an API, we hit their API and then run jobs on the chip. In the case of D-Wave. So that's what they call an annealer. Think of a simple quantum computer, but it does optimization extremely well. Then there's the gated computers, which most people are probably familiar with. If you're talking IBM or Google or Rigetti or IonQ, those are all what they call gate model computers. So think 1D on an annealer to 3D. The chips can do magically more things, but they're extremely hard to engineer those. So just to give you an example, on the D-Wave, there's a new one out there. It's called the Advantage 1200. The Advantage 2 is 1200 qubits. 1200 qubits, you go to IonQ and they've got 35 qubits. You're like, well, obviously I want the 1200 qubits. Well, maybe you don't, because these 35 are gated qubits, gate model qubits, and they're interconnected in more ways. So you can do a lot more with fewer qubits. So it's very difficult. It's always an apples oranges comparison when you're looking at the quantum field to a large extent. And it's very complicated. And it's a lot of really bright people working it. They've been working a long time, but I have to say that we're starting to see some really interesting progression across the industry and bringing the state of the art forward. And D-Wave's doing some great work. IonQ's doing some great work. My hope is that we'll have a lot of successful hardware players, because that means that we'll have a lot of capability. We work hard to be hardware agnostic and just be able to run jobs on any of these as they bring the level of the hardware's capabilities up. Then you start thinking about, wow, where can you take this? Just kind of limited by your imagination when it comes to the Gen AI side of it. That's where it gets pretty exciting, because there are many applications for quantum into that space. And I think people are just starting to explore that now. One could argue that we have a bit of an edge because we've been working in the quantum space now for a number of years. We've got one patent granted in the quantum space. We have some others pending. We primarily have proprietary IP. There's a few aspects of what we do. We do patent. In fact, our Seeker Gen AI offering has 4 patents on the back end on that. There's some value to that, arguably. I could argue it either way in terms of patents.
Could you try to give me some sort of visual example of how you're using generative AI with quantum?
Sure. Maybe to take a step back, just so we're all on the same page here a little bit. So Gen AI, we've been working in Gen AI now for several years. We've been working on training models for a couple of years. So that's sort of one effort. And then there was this other effort, what we call Secret right now, this has been, we probably don't have time to go to all the background, but except to say we've been doing the core Seeker technology in terms of a retrieval engine. That technology we started working on about 14 years ago, and we kept iterating it and deploying it in different modalities along the way. The nuclear power plants is a good example. So you walk into a nuclear power plant, they'll have about 100 million documents sitting there because they've been operating for decades. They'll be sitting in 32 databases, usually 30 some odd databases. So there's no ad hoc federated search capability. If you think of the plant as an organism, it has its own vocabulary, and each plant has a vocabulary of about 500,000 terms that are unique to that plant. So those would be part numbers, identifiers, you name it. So we built a system, the retrieval engine, a search and discovery engine, to go find all that stuff and to make associations. We took our Q from a number of different approaches, one of which is LSA, latent semantic analysis. It's been around forever. It's been the weapon of choice of places like NSA for years. Think of it as you could take massive corpus, a big pile of data, and you can squeeze it down to just the important stuff that you're looking for. You needed quite a bit of compute to do that. We actually developed our own approach to LSA. Instead of the champagne version, it's kind of the beer version, but it's the 80% solution that you don't need a supercomputer to run it on. So we developed all these core technologies along the way. It was actually March 23. I was this close to shutting down the Gen AI program. We were just having all sorts of problems training up and fine-tuning LLMs and get them to work consistently. There's a lot of science and there's a lot of art and all that, I would suggest. And it was on a Wednesday. I remember this because I was really ready just to shut it down. And our lead gets on the VTC and he leans into the camera and he says, "It's alive." I'm like, "What do you mean it's alive?" He goes, "It's working." And he got it works with the seeker back in the retrieval engine with a bunch of modifications. So we ended up creating a RAG, what's called a RAG today in the Gen AI space, Retrieval Augmented Generation. And quite simply, it looks at like ChatGPT as a reasoning engine, and then you bolt up a corpus, you bolt up knowledge, your data that you're interested in, and then you force that LLM to just reason against your data and not bring back artifacts from its training, which is really important. So we got really clever at doing that. We got it rolling in March, then we iterated it in summer. We went into beta and went through this long beta until late Q4. And then we launched it, Seeker that is. So it's retrieval augmented back in. We're using ChatGPT as a reasoning engine. We're going to release our own model, our first Seeker model. So you'll have 3 choices for the hosted, and then we'll be pushing this up into secure deployments, on-prem, air-gapped installations model, running against massive data sets.
Oh, that's amazing, because that is the big problem that everyone's kind of looking for a solution, is how to like take my company or my nuclear power plant's data. And it sounds like you've built your own application that can just, hey, let's tap into these different LLMs. Let's build our own LLM. And then, hey, you customer can have, or client can have access to all of the data that you have in a secured, contained way.
Absolutely. Yeah, they call it different things. I think of it as a back-end search engine. They call it retrieval engine. You need to retrieve actionable content. You need to be able to force the LLM to just generate that nice natural language response based only on that content. And then you need to be able to verify that. And we handle all those aspects.
Like even with ChatGPT, like 1% of the time it could be bugging out or hallucinating. And you have to kind of verify, is that accurate? Because it needs to be accurate.
Absolutely. It's really interesting. If you think about these models, we think about this stuff a lot. You know, we're reading papers every day. We use Seeker to read all these papers. We actually have archive. I forget the AI space. I think we've got like 60 some odd thousand AI articles that we've actually found some interesting things to focus on, just basically using Seeker, eating our own dog food, using Seeker on archive. It's really been fascinating. And that's an example of running it to scale across a large corpus. If you think about these LLMs, they are always hallucinating. That's what they do. And those hallucinations can either be constructive or not constructive. And a not constructive example would be that attorney a few months ago, this kind of semi-famous case, and a lazy attorney, one could argue. He used ChatGPT to come up with a brief he was doing or something he was filing with the court, and he never bothered to check the citations, which ChatGPT conveniently just made up. And the judge caught him on this, and he got his hand slapped pretty hard. But that's an example of hallucinations. They're next word prediction engines. And we could talk at length about other behaviors, interesting behaviors that people are benchmarking, identifying, and attempting to benchmark that make these things very interesting from a kind of a sciencey standpoint that we're quite intrigued with. So it's a fascinating area. And I have to tell you, I've been around for a while, and I've lived through a few. You know, there was this thing came along in the early 90s, late 80s called the internet. And I was busy making computer games, and I'm like, it's kind of a cool tool. I didn't really think about going into it and building a business around it. It wasn't interesting to me. And when Gen AI came along last year and we got it working with our technology in March, it was like, this is amazing. We really have to be a player in this. We've really made a huge commitment in terms of pivoting the company, focused on Gen AI and bringing quantum into it because of our core capabilities and our track record on quantum. I've got guys that we hired out of Los Alamos lab. They had their own D-Wave for 5 years. Arguably, they probably know how to run a D-Wave as good or maybe even better in some cases than the D-Wave people. So we have that depth of bench. So we've applied that to how can we bring quantum to Gen AI in productive ways. The low-hanging fruit is, if you could reduce the amount of inferencing required to get a response and be able to scale it against much larger data sets, that would be pretty cool, because you wouldn't have to be using half the energy on the planet to do inferencing. I mean, if people start looking at, people were upset with Bitcoin and cryptos. That's a drop in the bucket compared to what you're going to see and which we're already seeing, and no one wants to talk about, we're already seeing in terms of the sheer inferencing cost and energy costs associated with conducting that inferencing. Now, a lot of bright people like the Grok chip, et cetera, haven't dug into it to understand the science behind that, the engineering rather, but they're saying that that's really a great step forward in terms of efficiency, right, for inferencing. So all those things will help, but you look at a quantum computer, an application like what we, on the intermodal, one of our deployments of our hone system at a port, where we'll take a queue of trucks, all of a sudden you got 20, 30 trucks and you got a 30 factorial problem. If you were to do that classically, you run an HPC, you might get a result back in a few months, and we can do a full cycle in 15 seconds and have the result. So we can know which truck to put to which crane that's most efficient in terms of all the movements and constraints.
You touched on something that become a theme on this podcast, and something that I've noticed is the energy consumption around AI. In the comparison with Bitcoin, with NFTs, a lot of the people were like, oh, this is so much wasted energy, so much wasted human power, people wasting their time on this just to get like a pretty pixel on the picture. And I've always been like, well, at least with AI, there's like a tangible benefit that you're seeing, and you're getting all this more productive output, and you're able to like scale yourself even just from an individual level to a greater extent, where with crypto and all this stuff, it's kind of this financial thing. You hope to get rich someday maybe, or have you have this cool artwork that's now just sitting in a folder somewhere. The use case for AI is way better than crypto, but can you speak to the energy costs there? And so you're saying that indexing, which is a crucial part of generative AI, it takes up like half of the energy consumption?
The terms are kind of like indexing, there's vectorizing, there's embedding, then there's the inferencing when you actually are doing a chat. When that goes off to the LLM, then it has to do the inferencing to come back with the predictive next tokens to create these words in the response. It's either Google or Microsoft, they're putting more data centers in, really with the justification to support all the AI, all the inferencing. It's a big deal. But I agree with you. One could argue the benefit derived from engaging with LLMs, with generative AI to solve problems, is of much greater value than NFTs maybe, right? But I have to say that as a footnote to it, I'm still a big believer in blockchain. I think blockchain is a wondrous kind of thing. And the problem is that hype cycle is down for now. It'll come back, and I hope it comes back in a productive way where we're not going to do NICAT NFTs. We're going to do really cool things with blockchain. And done right, those are not high overhead kinds of things. Solana and all these other blockchains for business processes and purposes. And I mean, just think about voting. Why did we do blockchain for voting? Wouldn't that, like, duh, that'd be a no-brainer.
Well, there's so many government uses for blockchain and societal uses for blockchain. If people are willing to become a node in the system, if you can do it in a way that like verifies you, it's incredible what could be done. You mentioned Grok there, and I'm glad you did, because Grok is being represented at ImagineAI Live in Las Vegas. The CEO, we talked with him and he was about to come, but he had some scheduling conflict, but they're sending their chief evangelist to a conference, Mark Heaps. He is going to speak, and we're really excited because it does seem, and this is a point that Chamath Palihapitiya has made on the podcast a lot, is the cost of compute is, if we can't get the cost of compute down, none of this makes business sense in a lot of cases. The assumption with all of this stuff is that the cost of compute is going to go down in the future as technology improves. I hope it does, and I hope the science is there to make it happen. And it seems like Grok is this company that is simplifying the chip and making it a lot more energy efficient. I'm glad that they're going to be at ImagineAI Live.
That's awesome. There's probably two fronts, right? There's the hardware front, and Grok's an example. Then on the software front, I think you're going to see a lot of efficiencies gained. We've already seen it. I find this fascinating. What my understanding is, GPT 3.5 was 6 months and $5 million to train. Then a number of months after that, there was an article that came out, and they were citing ARK Investments, Catherine Wood. They were predicting by whatever it was 2026 or 2029, you'd be able to train a Chat GPT 3.5 level model for like $1,000. And that very same week that dropped, somebody did it in 3 days for $600. There's two philosophies. There's the big foundational models like ChatGPT, like Gemini, like Claude 2. So you have these companies that do these big raises, right? They do hundreds of millions of dollars. If you look at the use of funds, a lot of it's just going for inferencing costs, right? So they can have the compute to do what they need to do to move the technology. So you have the big foundational front, then you have the open source front. We're big believers in the open source front. For a host of reasons. I think the efficiencies on the compute side, there's a lot of really robust open source models that you can do great things with that are on a level with the large foundational models. I have a little bit of heartburn with some of the benchmarking that goes on. And I'm not sure how they get to some of these benchmarks. It's quite interesting. It's sort of like EPA thing. These guys they're basically jury-rigging the equipment to get the best EPA mileage. And I think a little bit of that happens in some of these benchmarking on models. So you kind of take that with a grain of salt. But what's cool is you just look at the trends, right? You want to look at the trends. So the trends are these models are getting better. They're getting lighter. And by doing so, less energy costs. So that's a great trend. Then I think you can bolt that into what Grok's doing and others. You've got a really kind of bright future, right? To do a lot of really cool things with AI without feeling guilty that we're consuming all the planet's resources in that process.
Speaking of consuming our planet's resources, it sounds like you're pretty familiar with nuclear energy and nuclear power plants. In America, I thought we haven't built a new nuclear power plant in 30 years or something. I know there's some interesting stuff going on with fission, I believe, and in Wyoming. Could you give us like an update on nuclear power in America?
I'll do my best. Okay, just to give it a little bit of color. So when I was young, I thought nuclear power is great. Then I went through a phase where like, God, we're going to kill ourselves. And then when I got involved with it, we've done training simulations for nuclear industry. We deployed the search and discovery seeker in these plants. And you get to know these guys. You really get to understand the plants. I've crawled around a few too many plants. It's really amazing what these guys do. They've been operating for decades. We haven't had a new plant in a number of years. I think there was one down in Georgia that they've been working on that may have been licensed recently. In California, a plant we're very familiar with, Diablo Canyon, it was going to be shut down in 24, 25 for political reasons. And then the politicos did an about face, and now they're going to keep it running for a while, which is good because the plant is very safe. They know how to operate them safely. There's a lot of tribal knowledge that goes into them. I don't really have concerns around the safety. They're a great source of energy. And the new generation, like Bill Gates, small modular reactors, there's actually one. I live just south of Jackson, Wyoming, a little town of Alpine in the county called Lincoln County. The entire county's population is 15,000. And at the south end of that county, there used to be a coal plant that was shut down, and Bill Gates has come in, and I believe they're going to put in a small modular reactor down near Kimmer. Wyoming's going to be a test bed for this new generation of reactor, which I think is great. These reactors, I think, hold a lot of promise. I've worked with the NuScale guys out of Portland. They're a competitor, small modular reactor. Best way to think about this is the fleet of, they call them fleets, the fleet of reactors in the U.S., and I'm guessing it's around 90 units, and that's across maybe roughly 40 or 50 locations, because like Diablo Canyon has 2 reactors, so 2 units there. Palo Verde, west of Phoenix, has 3 reactors. So you have these legacy systems, and most of them are water pressure vessel reactors. There's 2 different varieties, but those systems were designed in the 60s. Think about that. And they're kind of analog systems. And those systems are, if there is a problem, you got to pull out a lot of manuals. You got to figure out, and they train for this, how to safely bring the reactor down in a safe mode, and everything's fine. And they're very good at that. But if there's a problem, it requires human intervention. The new generation of reactors is like, oh my God, we got a problem. Quick, don't do anything. The whole system is sort of self-healing and shutting down, which is, I love that measure of safety. And I think that if we had the political vision and leadership and will to support and encourage the propagation of this next generation of reactors, would be a really wise thing, because we could basically power this planet, or at least the U.S., in a very efficient, cost-effective way. That's only because there's no political will to do this.
The one bright star is what Bill Gates is doing in this new kind of type of reactor, the new power plants. aren't on the way for a while until political will gets there. And then meanwhile, China, I think this year they've opened the same amount of nuclear power plants that we have in total in America. They've opened new ones this year, and they're just moving full force into it.
Yeah, I don't know the latest numbers, but I can tell you a few years back, I met with a delegation from China, their equivalent of their NRC, the Nuclear Regulatory Commission. Their plan was to have online by, I forget the date, 2030 or something, like 1,200 reactors. But it's still, even at that level, it was a small percentage compared to their coal plants, because they're still bringing on like a new coal plant every week or several every week still.
I'm reading this book called The Rational Optimist. It came out like 10 years ago. The thesis is how humans, what makes us special is that we were like our trading and how we naturally trade with each other. We've kind of evolved around that because, as we specialize in things, we're able to do more and be more successful and productive and prosperous. It's just insane to me, everything that's going on in this day and age. Like we thought, when I was going in college and stuff, I thought everything's moving so fast. Like, how can we keep up with this? And now it's 15 years later since I left college, and everything's just moving even faster, and all these different fronts and all this different, so much more consumption, so much more production, and we're still on the same planet. It just blows my mind sometimes.
I think about this is that never have we had so much technology, yet we live in a desert of true information and a desert of reasoning and critical thinking. The resources that we can avail ourselves to are, they're endless. They're absolutely endless. Maybe that's part of the problem. Where does one begin? Where does one concentrate? And where is the truth in what one can access? I would almost suggest that kind of back to the blockchain discussion. Maybe there's some opportunities in there to lash up blockchain to content in ways that we can be assured of source truth. To take that a step further, I know, Chris, you know this with deep fakes and everything with AI is becoming quite adroit at creating content that we as humans have a difficult time discerning from the real. And that's only going to get worse. We're going to have to start thinking about, some people are, thank God, thinking about ways where we can understand what is real, what is true, or at least have an audit trail, then that we can make those decisions we want to believe in.
How many employees do you have?
I think we're sitting at like a little over a dozen folks in the company. When
you're talking about all this data, like you're saying you're feeding all these AI papers, where are you keeping all your data? Do you have your own? Are you outsourcing? Is it AWS?
We use Azure, and we also deploy on azure.gov.
What do you think people are getting wrong about AI?
That's a really good question, and I can speak to that. So from experience, I think this is totally understandable too. There's a lot of misconceptions about AI. A good example of which is you start talking to people about GenAI or ChatGPT, and quite a number of people I run across are like, yeah, we need to get some of this AI stuff going and it can make our lives really easy. There's no easy button. An example of that is just the ability to interrogate, I'll call it interrogate an LLM, they call it prompting, but to prompt and prompt effectively is a skill unto itself. In fact, perhaps the most brittle part of the entire process, I would offer. We tell people simple prompts, simple answers, complex prompts, you can get more robust or high fidelity responses that arguably should have more usefulness depending upon what your use case is. Are you integrating this, baking this into work process flows? How are you doing that? Could you do template out some prompting to streamline things, et cetera, et cetera? Or are you looking at data and trying to understand really what's in that data in ways that no one's looked at before, kind of with your analyst hat on? And that's where I think AI has a lot of value, is being able to use it to really push into that data in ways that one normally would not be able to. I think that's where there's some value. I'd be happy to show you just an example of that with Seeker if you'd like to see just how the system works.
Let's do something kind of fun. I mentioned papers. We could do movie scripts too. That's kind of fun.
So you have a catalog of movie scripts?
I downloaded some movie scripts and on my local, and then I just dumped them into the browser. And then what happens is it takes it and we convert to clear text, encrypt it in flight, push it up into Azure, and then we do some processes on it there, and then it rests there. Your content rests securely encrypted. We never get to see it. And we also do all the vectorization on dedicated hardware, so it never goes out to OpenAI. The only thing that OpenAI sees, if you choose 3.5 or 4, is just what we push over in the context window. And those, I'll show you what gets pushed over, so just snippets. So, and then you set the API settings so that they promise never to look at it, and they promise not to train against it, and they promise to delete it every 30 days. So to the extent you're comfortable with that, it shouldn't be a problem. You can take, I've seen this where they've taken a prompt and they have taken every word and they've scrambled all the letters except for the first and last letter, and the system understands it, which is kind of mind-blowing. Your goal is to determine the strongest and most compelling story elements. Report back the top 5 with an analysis. We go ahead and we do, our retrieval engine is going and hitting all of those 12 screenplays and then pushing back the information to ChatGPT 4.0. Okay, let's go ahead and do the explain. So we click on here. Now this is from page 115 and 185 of the Butch Cassidy and Sundance Kid script. This is this highlighted snippet. These sentences are what the system returned, and is what got pushed into the context window, what we call a hyperprompt, along with some other instructions for how the LLM should respond. So here's all the content that was pushed into that response, and it goes on. So now we have full citations, full verification. Now the next one is kind of, this kind of blow you away. So this comes out of, we've done training and tools for advanced analytics for intelligence analysts in various organizations in the government for years. So there are certain things. There's one thing called link analysis. If you see these crime detective shows, there's always somebody has a board with the pictures of bad people or suspects, and they're using yarn to connect them, and they'll throw some Post-it notes up. Well, we kind of do this, but we do it in an automated fashion. So what we have here is we call the inspect tab. And this is extremely powerful. There's actually a patent just on this whole thing. So this is essentially link analysis on all the content that was pushed over to create that nice little response. And it's showing you much more. It's very high fidelity. So just to give you an example, we can take this and we can go to the highest. This was the strongest signals were around Butch and Cain here, for instance. It's interesting with Cain. We can go to the results here. So there's 14 passages that deal with Cain himself. That's interesting.
So these are words that, like, the most referenced words in the scripts?
Yeah, so here's of what we asked here and the response that was conducted, and of all of these results that we see here, there's quite a few results that come from a number of these scripts. Then this is another way of looking at the strongest signals and concepts, the strongest signals to include concepts, phrases, and terms. And then we create those as nodes, and then we connect those nodes. So for instance, if I'm looking at, here's a car. If I click on car, it's going to, now only those terms that we're dealing with car are connected now. So if I'm doing kind of a criminal network analysis, maybe I'm looking for bad guys. I can find bad guys that are not in your immediate network, but in tertiary networks, as an example. It's sort of like the criminal network thing. I know you, Steve. I don't know Steve, but Steve's a bad guy. There may be association knowing you, right? Kind of thing. So this is just different ways to look at the data. Again, it's pretty hardcore. But if you're doing anything that is mission critical that you're applying AI to, I would suggest you want to be able to know where it constructed its result, and then you want to be able to look and be able to interrogate it further.
You basically make a library, like a folder of, and upload all the content, the data, documents that you want to analyze, and then your seeker program can do that for you. And just use that data.
Yeah, and you can go simple stuff. You could just say, just summarize, right? Here's another document, and What's a manual? It's like an 1,800-page manual for a Boeing 707. And I can actually have it create a curriculum for training using AI.
For a new employee to read an 1,800-page document, not very time efficient, but to be able to, give them the main points and test them on it or train them on it.
Exactly. So this is the 737 Flight Crew Operations Manual. So we just ran Seeker against this entire document. So anyway, it's pretty cool. It's pretty powerful, and we really minimize the hallucinations which we talked about earlier, and that's really, really important. And we have full explainability of how it constructed its response.
What are you most excited about with AI, your company in particular, and the space you're working in?
Well, I have to pinch myself on that because for a host of reasons, things sort of coalesced late last year and early this year. We determined that, first off, someone's going to build AGI. In fact, I'm going to suggest a lot of people will produce AGI, artificial general intelligence. That's sort of the next big thing, right? We have Gen AI, it's going to go to AGI, and then then they say, well, then it'll quickly hockey stick up to super intelligence. We spent a lot of time looking at this, thinking about this. We determined that from a technical standpoint, we can do this with quantum, and it's not we just need to do this one quantum process. It's a bunch of quantum processes that you have to develop and aggregate to get to an AGI mode. So we went through the technical scrub on that, and we did our homework, spent time looking at that, came up with a design. We took a pause and said, do we want to do this? Do we want to be the guys or one of the guys that come up with AGI, quantum AGI, because that's what we're proposing doing. There's a bit of soul searching for me and all the big brains at Savant X. I got so excited about this. And I'm like, if we do this, do we want to take on the responsibility of doing this? What does that mean? What is that responsibility? And so we wrestled with that for some time. At the end of that process, we came out, and this is how I've rationalized it. We can do this. We're going to do this. And this will give us a seat at the table, is my belief, down the road, whether it be policymakers, whatever. We'll have some street cred, and hopefully we can help influence how this is handled from a regulatory standpoint, from an implementation standpoint, from a philosophical standpoint, you name it. Because I will guarantee you, whoever does it, and there will be many that do, I think that'll do AGI, there'll be different flavors of it, just like there are different flavors of Gen AI today. You will have people that will start bowing to the AGI god. You watch. It's going to happen. And that's not going to be a healthy thing. So I think you got to kind of get out ahead of things a little bit, think about stuff like that, and be in a position to hopefully at least have a voice to try to help understand and to help others to understand and to guide, to do this in a way so that this becomes a very positive thing for the planet. Because every technology is dual use. So I want to stay away from the evil side of this. And I think the only way you can do that is to be engaged. You have to be engaged. For me, from a career standpoint, this is kind of my swan song, and my partner, David Osby. We've done a lot of cool technology over the years, and this is no harder than things we've done in the past. We look at things from a technology risk standpoint, look at all the facets of what goes into it, and what's the risk associated with each one of those steps. It took me a long time. Projects kind of a running joke, and David and the team would say, this is non-trivial, Ed. And I'm like, great, well, when will it be done? It took me a long time to figure out that non-trivial basically means this is almost impossible from an execution standpoint, system design, programming. Anyway, that's our mission, is to create quantum AGI. And we just started that journey first of this year after going through those steps of analysis and soul searching. That's what we live and breathe now.
That's amazing, Ed. Wanting to build one of the AGIs that will be out there and used in this world, I think is a very monumental and important task. It's an honor to be able to talk with you about it. It does seem like an arms race in a sense. You don't build it, somebody else is going to build it. Multiple people will build it. And right now, the competitive advantage is with the US in general, but other countries are working on it too, I'm sure. And if you can realize that and want to do it yourself and have a seat at the table, like you said, and for good, is very important.
It's really fascinating if you think about it, because we're this little company and we're based out of Wyoming. Our research center's in Santa Fe, New Mexico, and we've got just a great team, really bright folks. I only understand about this much of what they're talking about when they get into all this theory and all these, we call it the quantum bunker. We have a basement in the research center, and we also have what we call the fight room, where they'll fight out different theories. It's pretty funny, and the walls are covered with formulas and math. I can only understand a very small fraction of it, but I don't need to. These are the guys that need to. But, it's what's really cool about it. Think about it. We're just this little company, and I'm sure there are other companies, probably even smaller than us, that are going to do great things in this area because you don't need to have a quantum computer, right? We can just make some API calls and pay our monthly fee. Anybody can do that. We can get inferencing costs from Lambda or Azure, wherever we want. Anyway, all these services we need to move the state of the art forward, they're all readily available and cheap, comparatively speaking. So it has lowered, it's leveled the playing field to, I think, people with bright teams and the initiative and the desire and the passion to do these things and to think out of the box. So I think it's wonderful. We're committed to this, and I'll bet you there's thousands of others committed to it. And I think it's all a noble goal.
Do you have a time frame?
We do. We're going to have, by the end of this year, we'll have what we call Quinn, for Quantum Intelligence Neural Network. And think of Seeker on steroids. It'll have a number of quantum processes baked into it. We already have one done. We'll be announcing here with a hardware partner probably late March or April. And that's just one of the processes that will be baked into this. And there's applicability right now for Seeker, which is pretty cool. So we'll take Seeker, move it into quantum-enabled Seeker. It'll be much smarter, be able to access a considerable repository of knowledge and do so quickly. That's really kind of key, right? Because if you want something to be really smart, it has to be able to access a lot of data and to know which data to access and then to reason against that data and to do so in real time. Because as a user, you're not going to want to sit around for a minute or 10 minutes or overnight. You need to have the response back right away. And that's where quantum can afford that level of response. That's what I would call for Quinn to have an MVP by the end of this year, but then next year will be the capstone. And that's another project that basically is being built and will be incorporated into Quinn. And that would be what we would consider to be an AGI candidate. So what does that mean? Sam Altman most recently talked about an AI system that, this is paraphrasing, reasonably emulates an average human in terms of intelligence kind of thing. I believe that if you have something that is smart across a lot of domains and can pull things together quickly and to carry on, this is key, carry on a conversation with you. So it becomes an active, not a passive experience, I think is key. And to learn from the interaction and to back propagate that into the models so that the models are continuing to learn, I think is critical. We did this at one of our deployments for something called Hone at ports in Los Angeles. We replicate out about 1 billion rows of data a day, and then we chew on that overnight. And it's something called dynamic terminal forecasting. So all the actions, all the business that happened that day, of which we were commanding most of it, we would do the scrub on it, do the compute, and then the next morning the system Hone would update itself. So it got a little smarter overnight. And that's really important because then that day we're saying how many cranes you're going to order up for the day's work. Here's the manifest of what the containers that need to be offloaded from ships, that need to go out of it, that need to be exported out of the yard, etc. So we have to come up with how many of everything do you need, then how many people do you need to bring in that day to work that shift. So the system kept getting smarter and smarter every day. And then we're also able to project out 2 weeks what the yard will look like, which is really important in terms of managing these ports. If you take that dynamic learning and you bake that into these LLMs, and I'll call variations of LLMs, because I don't think you're going to see AGI with a LLM. I think it's going to be a lot of LLMs and different flavors of LLMs to bring this all together. Then you have a very resilient system. You have a system that learns across different dimensions, and it's always learning, and that's what you need. And then always learn, like if it's you're interfacing with it, Chris, it's going to start knowing you. It's going to start knowing what's important to you. It's going to start then making recommendations. Oh, hey, this is a great question, but did you think about this? Then it becomes a real tool to you, and you have to be Believe me, there's a lot of privacy, confidentiality aspects of this that we are extremely concerned about. We've already baked into our roadmap to protect the users. That's a very high priority for us.
It's a dream right there, is to be able to have an AGI that you can interact with, pushes you, that pushes back, that prompts you to do something as well, then learns from you too and remembers what you are. And so like hypothetically, somebody could have like a trusted AI agent that's always there with them. If you choose to have this all powerful agent that just augments your life and can help you in so many different ways. Do you think by 2025?
I think by the end of 2025, we'll have a working proof of concept of AGI. I say working proof of concept because we're not going to be obsessing over response times. I'm making this up, but if it takes 10 seconds to get a response back at that point, but it is powerful, I'm not going to obsess over that. I'll leave that to teams of people that are really good in those areas to productize it.
Well, Ed, that's a hopeful note to end on. So I had an absolute pleasure talking with you. Thanks so much for jumping on. I can't wait to meet you in person at the ImagineAI Live Conference in Las Vegas.
Likewise.
It's going to be a lot of fun.
I would add to this, we were talking about where people get their information and social media and this and that, and can we trust it? One of the cool things about going to a conference like Imagine is you actually get to meet real people, and we actually get to carry on real conversations and learn from each other. And we can trust that exchange, right? That interaction and exchange. That's really powerful. It's kind of old school.
Absolutely. Well, see you in Las Vegas then, Ed. Pleasure, and talk soon.
Thank you, Chris. Pleasure here. Thank you so much.